the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. At the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
Well, thank you, Professor Sarkar, for inviting me. I'm always passionate in sharing information, especially the things I'm working on. But before I start, I want to make a disclaimer. This presentation does not represent New Jersey DEP's views, and the content of this presentation are products of research and experience of, based on what I've worked at Hydropool and DEP and my observations. So I'll be talking about surface water quality and how it is managed, and briefly go over the process. One question, how many of you know what a watershed is? So I won't go into that much details, but I'll just gloss over. I'll talk a little bit about sustainability, but many of you already are aware of the concepts. And then I'll give a high-level overview of how the sustainability principles are intrinsic to the surface water quality management, and then an example of the application. So what affects surface water quality? The various pollutants get into the surface water, which may be lakes, rivers, streams, ocean reservoirs, through various pathways. The sources can be anthropogenic or natural. It could be the spills or accumulation from sediment. It could be the flow alteration, which affects the surface water quality, the manufactured chemicals going into the surface water through various pathways. Urbanization has a tremendous effect on the surface water quality because it increases the imperviousness and allows more runoff or precipitation that falls to go to the channels and the surface waters. And agriculture, a lot of pesticides, fertilizers, and you're probably aware of the fertilizer law that took into effect, I think 2 years ago in New Jersey. And it can be natural. It could be the naturally occurring biology, the hydrodynamic or hydrology, and we have a guru over here for the hydrodynamics, Alan Bloomberg. It could be the geology. For example, the arsenic occurs naturally, and not only in New Jersey, but several places in the state, in the country. It could be the land use. If it's barren land, as opposed to a forested, it could have an impact on the water quality as well. Climate, I'm not going to go into that, it's a debatable topic, but it also has an effect. So what are the several pathways? We have the surface water in the center. Pathways could be the groundwater or the soil. The pollutants could be adsorptive salt particles, gradually leach into the groundwater and the adjacent surface water. It could be the air through dry weather and wet weather deposition. And I have these two in the vertical, non-point sources and point sources, because I wanted to point out that there are two basic we divide the sources into two types, points and non-point sources, and sometimes it's ambiguous. But generally, point sources implies anything which has a structure associated with it, like an outfall. So the discharges or the treatment plants or the stormwater outfalls, those are point sources. Whereas the air deposition, and that could be a non-point source, or the direct runoff that goes into the surface water, those are points, non-point sources. So when you're trying to manage the surface water quality at a particular point, you're not actually going to look at that point only. You have to think about where the water is coming from, and that's where the concept of watershed comes in. So watershed is basically if you hold your palm like this and drop pour a drop of water at any part, it will come into the center where there is lowest elevation, and then it goes to the pour point to the lowest elevation of the area. USGS describes it as a precipitation collector. The New Jersey Administrative Code, NJSC 7:5, defines it as a geographic area containing all the lands from which water, sediments, and dissolved materials drain to a particular receiving surface water body or to a particular point along a receiving surface water body. And it's also known as a HUC, or Hydrologic Unit Code. So in this figure, the different areas with different colors, they are the watersheds for those streams, for individual streams. And when you combine them together, it becomes a drainage basin. So multiple streams, their watersheds combined together, drainage basin. So the concept of this watershed, based on literature, it started probably from millennia. It existed. However, John Wesley Powell from USGS, he defined the watershed, had a more, what should I say, a definition for watershed when he was trying to mitigate the state boundaries, the effect of irrigation on in the state boundaries, and published Lands of the Arid Regions of the United States in 1875. Going forward, if we move the timeline later on, from watershed, I'll come to the surface water quality. So in the mid-1900s, basically the awareness of the surface water quality became more prominent. And Rachel Carson, I don't know how many of you have heard of Rachel Carson, mostly whoever is passionate about environment.
No, there's a certain age cutoff.
I didn't think so. It was published in 1962. She had published a book, Silent Spring, in 1962.
Yep.
And when I was in college, undergrad, I read that book, and I was a civil engineer initially. My major was civil engineering, and I liked water resources, but that book actually made me more passionate about environment, and that's why I chose to do environmental engineering. So going forward, again, in 1970s, that's when the regulatory revolution began, and that's my term, regulatory revolution, because in 1971, EPA was established, New Jersey DP was established in 1971 as well, and the Clean Water Act was in the 1970s as well. Although on a federal level, the work started long before, and there are studies being done in 1950s and 60s as well. From the 70s, we have come a long way. Prior to 1970s, most treatment plants probably had primary treatment or may not have. Some may not have primary treatment also. We have now secondary treatment in most of the plants, and some have tertiary treatments also, the third stage. The policies nationally and internationally changed. The resilience on the renewable sources increased. We started documenting the importance of renewable sources and started practicing and implementing them in the projects. the management itself became more holistic, and it became a multi-use approach. So it was not only the water quality that we were looking at. We were looking at multiple uses like society, economy, and as well as the water quality. Then came the concept of integrated management, which constitutes land, water, and other natural resources, lifestyle, human behavior, engineering. So it became more integrated, and it became more overall holistic. So what do we have now? What is the process of surface water quality management now? It has become more adaptive. We take into consideration the cultural and social aspects while planning and designing. That is more, when I say adaptive, the technology is always, we embrace technology, so any changes are incorporated, and it's institutional, it's, the politics are also incorporated. It's more comprehensive, multiple programs and resources are involved, multiple endpoints are looked at. And eventually there are three goals. We look at the ecological health, the efficiency or the economic health, and social and human health. So those of you who are taking the sustainability course, you will know that these are the three pillars of sustainability. And although the sustainability and development term was introduced by United Nations in, I think, mid-1980s, these were intrinsic, and this had become intrinsic. So the management of surface water quality has become evolved into the process so that sustainability is an intrinsic element or component of the process. So let's look at individual components of how we basically manage. We have the regulatory framework on the left. We have the various actions that we take. We have public involvement. And all these are overlapping and intertwined. It's not that we can do anything independently. So in the regulatory framework, we have the various policies, the plans, we have the scientific research that feeds information to the policies and plans. We have the standards, which can be numeric or narrative. We have states, federal rules. We have on a more local level, we have ordinances. We have permit limits, non-point source control. The NPS is non-point source. And the compliance enforcement obviously is part of it. And TMDL is total maximum daily load. That's part of the requirement for the Clean Water Act. And more recently, we have also started promoting and incorporating into the plans for restoration and protection. So if a water body is impaired, we do TMDLs. If it's not impaired and healthy, we do protection plans. And if it's impaired but it's more from non-point sources, we do restoration. And in even in the regulatory framework, when we are developing the standards or developing the plans, public involvement is intrinsic. We do public partnerships. We have various groups like science advisory groups, and like Dr. McCary was the chair of the science advisory group from the department. We do citizen outreach and public education and stewardship. Actions, we strive to improve our science and technology and try to incorporate them into every aspect of the planning and implementation. We do monitoring, and that's an integral part because we have to assess based on the monitoring data. We have to collect data to know how the waters are and whether they're improving or not. We remediate the bad waters and the stressors. We try to remediate not only the waters but also the stressors. We do restoration and protection, and we implement the plans that are developed. And then periodic review. So it's not that we are not looking at it we do once and then forget about it. We do periodic review, we have to go back, we have to self-assess. So even then, there are uncertainties. However, the adaptive and integrated management lowers this uncertainty because we try to always do the assessment. We try to review where we are, how we can do better, how we can adapt to the changing scenarios, and we monitor based on that. If we get new information, we update plans. We have public outreach based on public feedback. We may incorporate new entities into the plan or change the plan, or so that we strive to reach the end goal of not only the water quality but also the social, taking into consideration the social aspects. So this is, you're familiar with this three Venn diagram or chart. But I wanted to show you because this is what we have on our DP website. So three pillars are economy, society, and environment. And all of them are not independent of each other, they are overlapping. We have the just or justice, environmental justice, which look at the impoverished areas, trying to preserve areas that generally could be overlooked. We have the economy and efficiency, which eventually leads into the sustainability water quality, but also look at the environment, and then obviously the society. And I will go into details a little bit in the next few slides, how the various components or various actions that we take pertain to each of these circles, or or should say, the pillars, each of the pillars. So for the environment, for healthy environment, the eventual goal is to protect the good quality waters, restore the poor quality waters, and to sustain the aquatic life and other desired uses of the water body. The technology is always changing. We try to embrace technology and incorporate them into the processes. We do economic impact analysis, and they're incorporated in planning while developing standards, while adopting the standards, while permitting and enforcement as well. We include the community through stakeholders, partnerships, as I told before. We have the Executive Order of 12898 from New Jersey, which empowers the communities and revitalizes and preserves. So as a result, we have an optimal solution that achieves our long-term goal of maintaining the water quality while maintaining the social and economic balance. So any questions until now? Okay. So I'll go over the example of how we, or how I have observed at the department, not department, I should say, in our division of water monitoring standards, how we manage the surface water quality. And that brings to a circle, which we call the Waterside Circle. And this is not new. This was created by a very smart colleague of mine, Sandra Cohen, back in early 2000s. So my point is that incorporating the sustainability principles is not new. It has been going on for a while. And it's intrinsic. So the first fundamental basis of this wheel is the surface water quality standards. And the research feeds information to develop the surface water quality standards. The next one is the monitoring. We have to monitor all the waters to know what the state they are in and whether they're improving or not. And recently there was a press release that the nutrients in New Jersey waters are improving, so they're declining in the New Jersey streams based on a new USGS study. Have you heard of it? Heard of it? It came out, I think, day before yesterday, and I heard that in the news, radio news yesterday. All the sodium is increasing in 2 streams. The assessment, so that's the assessment. We have to assess those waters to know where they are and what we can do, whether they're improving or not. And then reporting, this is mandated by the Clean Water Act. Every 2 years we have to report the statewide water quality and as in the form of 305 report. And there are other EPA measures like WP 27, 28, SP 12, and so on and so forth. But most important is if a water body is impaired, then we have put that water body or the HUC 40 to a 303 list along with the parameter or pollution that is impaired for. And what's the result? The result is if it is on the 303 list, then we develop a TMDL or restoration plan or protection plans. And of course, there are some pollutants like the legacy pollutants which we can't do anything about other than wait for natural attenuation. Or do, call it Superfund site, like the SAIC is called the Superfund site, and then we dredge up the sediments and remove them. And then the implementation of these plans through non-point source restoration grants, which was previously called 319 grants. And then we have the permit limits, the non-point source controls, the MS4 program, and the pollution minimization plans. And finally, the compliance and enforcement. And then again, we go back to the research and we review the standards every 3 years to see whether they're outdated or not. If they're outdated, we re-adopt them based on new information, and then the cycle continues. And in each of these, public involvement is in the core. So it's an integral part of the process. So let's look at a little bit more about the standards. There are several rules in New Jersey DEP, and watershed management uses many of these regulations, and this is not comprehensive, this is only some of them. And what stands out for our purpose in my division of water monitoring standards is the surface water quality standards. So the surface water quality standards has 4 parts. Designate uses. We can have the aquatic life, which could be chronic or acute. Drinking water. Agricultural and industrial supplies, navigation, and recreation. We classify the waters, all streams and all surface waters basically, based on type and designated use. We have the fresh waters classified as FW1, which are the anti-deck waters and are the highest quality. So they basically are already meeting the standards, and we preserve them through the anti-degradation policies. FW2 waters, which are the fresh waters with trout protection, the TP is trout protection, and TM is trout maintenance, and NT is non-trout. So trout is the fish. Saline waters can have SE1, which is SE is saline estuarine. SE2 and SE3 are downgraded waters. So SE1 are the designated uses are primary contact, so you can fish, swim, boat, so you can come into contact directly with the water. SE2 and SE3 are downgraded waters, and some waters, especially in the New Jersey harbor, which are downgraded based on an use attenuability study that was done in 1985. And then the SC is the coastal water, so all the beaches are SC waters. And then we have the pineland waters, and pineland water stands out because based on the geology, the pH in the water is really low. Then we have the water quality criteria, which are the numeric thresholds, which are meant for aquatic life protection or human health protection. And then there are several policies, like anti-degradation policies, so that the healthy waters do not degrade. We have the mixing zone policies. We have surface water quality variances, and that's something we are working on right now based on EPA's update in 2015. And then there are several general and technical policies which allow us to assess and implement those numeric criteria, numeric and narrative criteria. So, what is the process of setting up the standards? So first, EPA, or the states, mostly like EPA, identifies the parameters and pollutants. They assimilate the data, they do the science and research, they develop the numeric or narrative criteria based on the classifications and designated use to address those designated uses for those classifications. And then comes the rulemaking of the state to adopt those criteria as a rule or part of the standards. Once it is adopted, EPA approves, and the standards are implemented. So I'll go a little bit further and describe the rulemaking process to you. But I also want to point out that the science drives the identification of the parameters and setting up the numeric thresholds. However, the implementation policies and the implementation and the assessment policies, those are driven by other aspects, and that's where the social and economics comes in. And the ultimate goal is making the waters fishable and swimmable and protection of human health and aquatic life. So the rulemaking process, it begins with the stakeholder involvement. So if we want to adopt a criteria, we have a stakeholder meeting. We inform the stakeholders, which comprises of all communities like academia, dischargers, enviros, local government, watershed groups. And then once we go through the legal review process, we have the public hearing where we document all the comments, we address the comments. We also do the impact analysis, and not only economic, but also social, environmental, smart growth development, housing affordability, jobs impact, and regulatory flexibility. So if you have any questions on any of these, you can ask me later. I'm not going to go deep into these. But my point is that these are all this impact analysis basically help us address if there are any economic implications or if there is any environmental justice implications, whether the society is getting impacted, and if so, how much are we balancing it? And eventually we have a well-balanced rule, and even if there are certain cases where the criteria is very stringent and it cannot be met, we have policies such as the variances to eventually get to that point of meeting the standards, but it's a phased approach. So the variance. And then we have the monitoring. This is a brief overview of like the various monitoring networks. So we monitor not only for the chemical parameters, but also the biological parameters. We have two networks, one for the freshwater, one for the marine waters. We have, and these are, there are several networks, but some of them I want to point out is a Slocum Glider. So we release a glider with sensors from Sandy Hook, and it goes across the ocean several miles, and while it's traveling, we direct it downwards, so it's like vertically it goes down and comes up and then comes back to the shore, and that way goes through several transects until it's picked up near Delaware. Then we are also trying to embrace the UAV technology, and that's something we are working on right now, to use drones to get water quality data and use remote sensing. So how do we incorporate the sustainability principles in monitoring? So we have a long-term monitoring strategy, which we have to develop for every 10 years, but then we review every year. So we review and we prioritize, we make changes if required, and we try to incorporate the novel technologies like, as I said, the UAV, Slocum Glider, all the testing methods. We build in the partnerships, we try to involve the public, and Professor Sarkar just mentioned that he is planning a project where he wants the high school students to participate. So that's really a novel idea, and we have the AmeriCorps program, which tries to do that as well, to involve the high school students and they go to schools and make presentations. We have several watershed groups that help us with our data collection. EPA is promoting the citizen science nowadays, so we get more data from them, and we have limited resources and they're dwindling, so we can't really keep up the work if you don't have the partnerships. And then the stewardship, that's a really important aspect, and it's not only AmeriCorps, but we have a couple of people only assigned for the stewardship program. So then assessment. Before we go in assessment, let me give you an overview of how we do the process, how the assessment process is. We divide the entire state into 5 WMAs, or 5 basins. So each of these colors on screen are each WMA. So every 2 years, we do a comprehensive assessment in each of these regions. This approach started in early 2000s. We moved away from it for a little bit. We started that again in 2014. So in 2014, we made, I think, the outer coastal plains of this area as our priority for the comprehensive assessment. And in 2016, Raritan is the area we chose for comprehensive assessment. But that doesn't mean that we don't assess the rest of the waters. It's only that these, for example, if Raritan, there might be like out of 958 Huck 14s, there might be 200 Huck 14s. So we really go into details in that Huck. We sit into a room, and I'll show a picture how we sit in the room. We bring in people from different programs, and we from permitting, from enforcement, from monitoring, and try to go in the weeds. And for the rest of the state, we have developed an automated program which automates the assessment process. So there are 5 basins, 958 hucks, 10 zones from the Delaware River, and we call this a rotating basin approach. The assessment process begins with the data solicitation. We give 3 months for everybody to submit the data. And for our assessment, we are very quality conscious, so all the data have to have co-ops that are approved by either state or USGS or EPA. Then we have a methods document which outlines the assessment process, what methodology we are using for each parameter. We publish that, receive comments, and then make updates as required, address the questions that come up, and then release the final. And then we have the data assessment reports. So the data assessment involves assimilation of data. We do QA again, and you'll be surprised, how much bad data is there. So for example, for 2014, or actually 2016, I downloaded 3.2 million records for discrete data. And out of 3.2 million records, after doing the QA, I had only 2.4 million records. So, and then we do the comprehensive assessment and then do QA again. And this is the picture I was talking about. You know, a group of us huddling together in a room with 3 projectors projecting different things. And this is a very tiring process. So the concepts of sustainability, like when how we involve society, is built into the data solicitation and the methods document. And once we assess, we again reach out to the watershed groups. For example, in Raritan, there are watershed groups. We reach out to them with the preliminary results, try to figure out what their input is, and try to combine them. We use technology like last cycle in 2014. I wrote a program in R Studio to automate the process. Prior to that, there was Jack Flommer who used Access to automate the process. So as we have newer technology, we are trying to embrace them. And we have periodic updates to stay abreast of the latest technology. And then we do the comprehensive assessment. And the reason for that is the water quality data automated assessment and the biological data assessment doesn't tell the whole story. There are nuances and there are stories in even which only the monitoring folks would know, or the enforcement guys who go there to check it out, they would know, which we, typing in our laptops and trying to code, we won't know because we always don't go out to the field. So we gather together a team of professionals and we look at all lines of evidences. And if there are some monitoring stations which have data or impairments showing that they're on the edge, we really dig deep and ask why it's happening. If there's all of a sudden a huge peak, we try to understand why it was happening. Was there a spill, or was there a breakage, a line, sewer line breakage, or something like that? And then GIS is our best friend. We can look at anything from the aerial views, right? So then comes the reporting aspect. So every 2 years we have to write the 305B report. And the draft report is released, we receive comments, we have to address them, and then release a final draft again. It basically lists, it has 5 lists in addition to other restoration work that is going on, describes the watershed, the comprehensive region, the plans, the vision. So it takes a holistic approach to the assessment process. However, the 5 lists that we publish are, first one is attainment. And when I say attainment, all parameters, so we have about 95 parameters or pollutants that we look at, in addition to the biological indices that we have. So all parameters are meeting. And it's very difficult to find in New Jersey, where all parameters are meeting. Sublist 2 is meeting for at least one parameter. Sublist 3 is insufficient data. And 4 is impaired, but no TMDL required. Oh, that's wrong. Okay. This is wrong. I should have corrected this. It should be impaired and there is a TMDL. 4A is completed. TMDL has been completed. 4B is other pollution control requirements in place. 4C is caused by a pollutant. And then we have the impaired list of sublist 5. and we introduced new sublists on the sublist 5, especially because we have naturally occurring arsenic, as I was saying before, that the impairments could be caused not only by anthropogenic sources, but natural sources as well. So 5A is for arsenic, which is naturally occurring. And we really have to prove to EPA that the sources are natural and it's not anthropogenic, and that's really difficult. 5R, so if the restoration plans are complete, we put that into 5R, and 5L is the legacy pollutants, for example, the legacy pollutants in the Hudson River or Passaic or the Hackensack or Narrow Bay. So in reporting, we again take into account all aspects of the sustainability. Like we talk to the multiple stakeholders, we involve the partnerships, we provide opportunity for the public to comment and review, we address those comments, we continually try to increase the efficiency. So like 4 years ago, before the automated program was used, it used to take like several months to do the assessment. Now it takes, it's like a, you have to press a button and it's done, although you have to do QA after that and before that. And then the reporting process is leveraged to identify and prioritize the watersheds and sub-watersheds for restoration. So while we are doing the comprehensive assessment, we look at and we try to identify whether further monitoring is required. We also look at whether we can identify potential locations for restoration, and whether a TMDL is required or restoration is required or a protection plan is required. We also look at whether the partnerships or the watershed groups, they are developing anything, any restoration. Do they have any restoration activities going on or not? So it becomes, it is not only improves the efficiency of it, also like incorporates the society itself. And the end goal is the environment. We want the healthy waters. Then comes the TMDLs. So I haven't described TMDLs. Do you know what a TMDL is? The TMDL, total maximum daily, of course Alan will know. Total maximum daily load is a sum of, it basically identifies the sources, and then through modeling, or should I say, it creates a waste load allocation and for the dischargers or point source dischargers or the regulated point source dischargers, and also creates the load allocations. So it allocates the loads, who can discharge to what amount. So it has two components. One is the load allocations for the non-point source and waste load allocation for the point sources. And then there's another margin of safety that we add. So TMDL or waste load allocations, if there are point sources, but if it's predominantly non-point source, then we do restoration. And if it's healthy waters, we do protection plans. And in all of these, public participation is integral. So when I say integral, the TMDL process, at every step, we do stakeholdering for that that region. If you are doing protection plans or restoration plans, we talk to the people, the locals, we do public outreach, and we try to gather information. 5 minutes? Okay, I'll do faster. And stewardship, and eventually it goes to prioritization and adaptive planning. And all of these, the science is incorporated as well as technology, fate transport modeling, and Alan Broomberg is one of the gurus over here. And then finally we have the implementation and the grants. So let's recapitulate the integral components of water quality management in surface water. So we have the standards, regulations, we do comprehensive assessment, we do reporting, actions or TMDOs, restorations or protections, implementation and enforcement, and all of these holistically, the public participation is integral. We take into consideration the water quality. The eventual goal is to improve, protect, or restore. Public is, as I said, is an integral component. It is fluid process. It's adaptive to changes, not only technology, but public perception, economic considerations are always taken into account, and policies. That's key. The planning, we also have a continuous planning process that we have to do every 5 years. In addition to every year we update our planning, and every step actually we may change what we have planned. It's not that if you have planned something, it's static. Affordability analysis is also a key element. While we are doing the standards and while we are implementing, there are policies which take into account the affordability of a particular community, where that particular standard or criteria is being implemented. So eventually we want to derive a most balanced and efficient solution. And integrated management helps that when we look at multiple users and multiple aspects. So that's how the entire sustainability concepts have become integral to the management process for surface water quality. So, any questions?